now we are going to learn the electric potential energy of an electric dipole in a uniform electric field. For this, for finding the work done or the electric potential energy of a dipole, first we need to consider a dipole. And this dipole is to be placed in uniform electric field making an angle theta. So let's draw the diagram. The diagram will be, first let's mark the uniform electric fields. These are to be the uniform electric field E. Okay. So now we are going to orient a dipole here. So the dipole is to be oriented by making a certain angle theta with this E. So how is to be oriented? Let this be the dipole. And it's making an angle theta. The distance between the dipole is 2a, and second marked here. And the force due to plus q is plus qe, and it's in this direction. And the force due to minus q is minus qe, and it's in this direction. Okay, so this is the figure for finding potential energy of electric dipole in uniform electric field. So now let's move into the derivation. For this, first we have to consider this dipole to be placed in a uniform electric field. Since it's placed in a uniform electric field making an angle theta, it has a torque developing in between these two dipoles. So the torque which is being developed in between these two dipoles is to be marked as tau is equal to Pe sin theta. Okay. So this torque is what makes this dipole to rotate in this electric field. It helps in rotating of this dipole in this uniform electric field. So that torque is to be marked as Pe sin theta. So if this dipole is rotated through a very small, let it be rotated through this a very small angle d theta, then the torque becomes, or the work done becomes, this let the work done, the small work done in moving this theta to d theta, making a small angle d theta, is to be marked as dw is equal to 2d theta, which is same as Pe sin theta d theta. What is this? Force into perpendicular distance, or sorry, force into displacement. Force into displacement is what makes the work, right? Force work is force into displacement. So what is the force here? Torque is the force here, and the displacement is d theta. Since d theta is a small angle deviation which is made by the dipole with regards to the electric field, so d theta is the displacement here. So the small work done in here is tau d theta. What is tau? Pe sin theta. Pe sin theta into displacement d theta here. Therefore, what is the total work done? The total work done can be found by integrating dw, right? dw is integrated to found the capital work. And what is this capital work? This capital work w is equal to integral Pe sin theta d theta. Now we are going to apply limits to this integral. What are the limits? From theta 1 to theta 2. Let the angle be displaced from theta 1 to theta 2. So since the displacement is a factor here, we are putting the limit to be in under displacement, that is theta 1 to theta 2. Now we can see that P and E are constants. So we can take it outside the integral. So the W becomes W is equal to Pe into integral theta 1 to theta 2 sin theta d theta. What is the integral of sin theta? Integral sin theta is equal to minus cos theta. Integral sin theta is equal to minus cos theta. This is the integration formula. So we are going to apply this formula here. So the W, the work done, becomes Pe into minus cos theta within the limits theta 1 to theta 2, right? So we are going to apply this limit to this bracket. So what happens? W becomes, the work becomes PE into cos theta 1 minus, sorry, cos theta 2 minus cos theta 1. What is this? Upper limit minus lower limit. This is the upper limit and this is the lower limit. What is the formula of opening the limit? That is upper limit minus lower limit. That becomes cos theta 2 minus cos theta 1. Now, let us assume that let the theta 1 be equal to, let the theta 1 be equal to 90 degree. What is cos 90 degree? Cos 90 degree is 0. So the theta 1 becomes 0. And let theta 2 be equal to theta, any angle, let it be any angle. So now we are going to apply this both values to these thetas. So what happens? W or the work done becomes PE into cos 90, that is 0 minus cos theta, right? Sorry, cos theta minus cos 90, sorry, upper limit minus lower limit, okay? So the work done, W is equal to PE into cos theta minus PE into, so we are taking a minus here outside, minus PE into cos theta. This is the work done. This is the work done by a dipole in uniform electric field. Now, this work done by a uniform electric field by a dipole is being stored in the form of potential energy. That is, this work which is being done by the dipole is to be stored as potential energy inside the dipole. That is to be marked as U. What is U? U is the potential energy. U is the representation of potential energy. U is equal to minus PE cos theta. So this is the electric potential energy. This is the electric potential energy of an electric dipole in uniform electric field. What is the electric potential energy of a dipole in uniform electric field? U is equal to minus PE cos theta. This is the formula. Now there are some special cases. What are the special cases? When theta becomes 0, when theta becomes 0, potential energy is equal to what? Minus PE. That is cos 0 is cos 0. This theta becomes 0. That is cos 0 is 1. That is the remaining part is U is equal to minus PE. Now, when theta is equal to 90 degree, that is cos 90 is 0. Potential energy of the dipole also becomes 0. And when theta is equal to 180 degree, potential energy is equal to PE. So from here we can understand that a potential energy of a dipole is to be maximum. U is maximum when theta is 180 degree and U is minimum when theta is 0 degree. Okay. So this is the basic derivation of the formula. This is the basic derivation of formula of electric potential energy of a dipole in uniform electric field. So I hope you understood this. Hope you understood the video. If you have any sorts of doubt, just please rewind the video and note the points down for more clarity. And if you have any other sorts of doubt, just comment below. I'll be replying your comments. And if you want the notes of these chapters, you can follow me on Instagram. I'll be uploading the notes and these derivations in Instagram. You can collect it from there. And please don't forget to subscribe my channel. Please do like, share and subscribe and comment. And I'll be seeing you in the next videos. So till then, take care, stay home, stay safe and keep learning.